date, and this date is celebrated as Pythagorean Day or Pythagorean Theorem Day. So let's discuss how it is a special day. So 16th of December 2020, if you look at the numbers carefully, it is 16 square is 256 and 12 square is 144, and if you add 256 plus 154 or 144, the total is 400, which is the square of 20. So that's why today is a special day, 16th December 2020, Pythagorean Theorem Day. And do you know the previous date which was celebrated as Pythagorean Day was 15th of August 2017. So let's calculate how that was special. And if you think about the next day, that is 24th July 2025. So if you look here at the date, when I say 16th 12 20, that is today's date, right? So 16 square plus 12 square is 256 plus 144, which is equals to 20 square. Okay, so that is your 400. And if we look at the next Pythagorean day, that will be 24th of July 2025. So 24 square plus 7 square, if you calculate this, 24 square is 576. You can check one of my video in math tips and tricks where I have explained you how to do the square of 2 digits and 3 digits. Okay, and 7 square is 49. So if you add them, it is equals to 625, which is square of 25. So welcome to Deep Tips on this special day. Okay, so I want to tell you something about this famous mathematician. In his times, he said the two tones sound nice together if ratio of their frequencies is a simple fraction. So this is just a simple thing that he analyzed, that when you are composing the music and two tones you are taking together, they sound very pleasant to the ears if ratio of their frequencies is a simple fraction, and simple fractions you learn in grade 5. So if you look at the things around you, very small things makes a difference with math. If you're good at it, you can make things beautiful. So math has its own beauty. So I'm waiting for my students to join the stream. Hey, hi Ruhan, how are you? So glad to see you on time. You are my punctual student. Yeah. Okay, so today we are going to do our second stream on trigonometric ratios. And this stream will focus on the angles. Okay, so let's wait for few more minutes so that everybody joins in and we start our session. So by the time those who have joined, they can write hi or hello so that I get to know, like how Ruhan does it every time. Yeah. Okay, great. If you know how it's a Pythagorean theorem day, absolutely correct. Yes. So this is the beauty of today. So those who are born on 16th of December can very well connect themselves with Pythagoras, right? Okay, so I want to tell you that what is special in today's session. I'm going to do two things today. First thing, we are going to learn about the ratios of different angles that are in grade 10 syllabus. Like starting from 0 to 90 degree, if you look at the curriculum of grade 10, we have 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. These few angles whose ratios you learn, right? But many times children just muck up the values of these ratios, but they don't know how they are derived. So my main agenda of today's stream is to derive the values of these ratios. And at the end of this stream we will learn the trick also to remember those ratios, because knowing them and remembering them both are important. So you can't just only know them, but at the point of examination when time is short, you need to apply the values in your questions. At that time you need to be quick. So at the end of the stream, after you understand the derivation, I'll tell you the tip and trick for learning the trigonometric table. Okay, so let's begin our today's class. Okay, so first trigonometric ratio that I'm going to do is 45 degree. It is the simplest one to understand. So how value of sine, cos, tan, secant, cosecant and cotangent changes with this 45 degree. Okay, so let's draw a right angle triangle. So this is my right angle triangle ABC, which is right angled at B. Okay, so if this is my 90 degree, this is my 90 degree which is at angle B, and angle A is 45 degree, then it is understood that angle C will also be 45 degree. So what triangle it is? Yes, it is my favorite isosceles triangle, where angle A and angle C both are 45 degrees. Okay, so doesn't matter if I take angle A or I take angle C. Here you will see that I will get the same answers because both angle A and C are equal here, right? They are equals to 45 degrees. So when you know this is an isosceles triangle, so let's take AB and BC as A. So we know that in an isosceles triangle, sides opposite to equal angles are equal. So that's why AB is equals to BC is equals to A. Correct? So let's write here that AB is equals to BC, which is equals to A. So we don't know what is AC. So let's make use of Pythagoras theorem. So AC square is equals to AB square plus BC square. So AC square is equals to A square plus A square, because I know the values of AB and BC. So I can write that AC equals to 2A square root of 2A square, right? So which is equals to root 2A or A root 2. We can write it as A root 2. So this is my A root 2. Now I know the value of all the sides. I know the length of all the sides of my triangle ABC, where AB and BC are equal to A and AC is A root 2. Correct? So now if I want to find sine 45 degree or sine of A, right? If I write sine A is equals to 45 degree, so I can write sine 45 degree. Correct? So yesterday, if you have watched my live stream on Introduction to Trigonometry, I taught a very interesting Pandit ji's formula. Pandit Badri Prasad har har bhole sona chandi tole. So what is the sine trigonometric ratio sine? Sine theta is equals to perpendicular upon hypotenuse, right? So what is my P here? We have already learned in the previous stream how to identify the sides of the triangle. So angle B is 90 degree. So side opposite to 90 degree is hypotenuse. I am just writing it again, so those who are watching it today, they just are able to connect with it. And this is my base because I am taking angle A, and this will be my perpendicular. Okay, so this is my perpendicular. So we have identified all three sides of this triangle, and sine 45 is perpendicular upon hypotenuse. So my perpendicular can be seen very well from the triangle is A, and hypotenuse is A root 2. So A and A get cancelled, so sine 45 is 1 by root 2. Correct? Same way, if I look at the cos 45 degrees value, cos 45 is base upon hypotenuse. So base is A and hypotenuse is A root 2. So if I cancel my A's, I get 1 upon root 2. Correct? So you can see here that sine 45 and cos 45, they both have same value, 1 by root 2, because the perpendicular and base are of equal length. This is an isosceles triangle. That's why both the values of sine 45 and cos 45 are equal. Now if I look at tan 45, so tan 45 degree, I know this is equals to sine theta upon cos theta, or sine 45 upon cos 45. And if you look at the Pandit ji wala formula, you can write base perpendicular upon base. Correct? So perpendicular is A and base is also A. So they both get cancelled. So I get tan 45 as 1, or if I divide my sine 45 upon cos 45 value, that is also 1 by root 2 upon 1 by root 2. So they both get cancelled and the value of tan 45 is equals to 1. Now if I look at the remaining three trigonometric ratios, so cosecant 45, which is just the reciprocal of sine 45, so that is equals to root 2. Secant 45, which is the reciprocal of cosine 45, that is also root 2. Correct? And now if I look at cot 45, which is the reciprocal of tan, that is 1. So these are the values of trigonometric ratios when angle your theta is 45 degree. I hope you are clear with the derivation of this angle. So I'll be back with tan 30 degree and 60 degree. Okay, so yeah, I'm back with another trigonometric ratio that is tan 30 degree, but I'll take both 30 and 60 degree together here. You must be thinking that in the right angle triangle, when we took 90 degree at angle B, like in the previous figure, if I show you here, we can take one 30 degree and another 60 degree. If you're thinking like that, that is also correct. But then I am not sure about the length of the sides. So that's why I'm not taking this triangle which I took in case of 45 degree. Now, when I'm talking about 30 degree and 60 degree, I have a better triangle in my mind, and that is equilateral triangle. So let's draw one equilateral triangle. Okay, so if you say this is my equilateral triangle, okay, and we know that in equilateral triangle each angle is 60 degree. All three angles are 60 degree each and the sides are equal. So each side is A. Let us assume that each side is equals to A, and these are my 60 degrees angle. But now when I'm talking about trigonometry, I need a right angle, right? I need right angle triangle. So how do I get that? So I can drop a perpendicular. So let's drop a perpendicular from A on side BC. Let's say AD is my perpendicular. Okay, so I got two right angle triangles. But now still I need to prove that triangle ABD and triangle ADC are congruent. So that I get the value for BD and DC, you can also say that when I am bisecting this BC, so it is A by 2, but it's always good to prove this. So if we take triangle ABD and triangle ADC, right? I have here angle B equals to angle C because they are equal, each 60 degree. Okay, then I have drawn a perpendicular, so I am clear that my angle ADB is equals to angle ADC, each 90 degree. Correct? Now what else I can take? I can take AB equals to AC. Both are equal to A. So I can say that triangle ABD and triangle ADC are congruent triangles by angle side rule. Correct? So we can write here triangle ABD is congruent to triangle ACD, because naming is also very important here. When I am writing the name of the triangles in congruency, so it should always be correct, ACD. So here also I should write ACD. Okay, so now this is my angle side congruency. So hence we can say that BD is equals to DC CPCT, corresponding parts of congruent triangles, and my angle BAD, that's angle BAD, and my angle CAD, that's angle CAD, is also equal. So they are also using CPCT, that corresponding parts of congruent triangles. So if angle BAD is equals to angle CAD, that means they both should be 30 degree if they are equally divided, and if BD is equals to CD, then they are also equally divided to A by 2 each. Okay, so let me change the color now. So we are done with the congruency part, and now we know the angles and the sides and everything that we need in a triangle. Okay, but still I don't know the length of AD. So to find AD, I can use Pythagoras theorem. AD square is equals to AB square minus BD square. As I can clearly see that side opposite to 90 degree is my hypotenuse. So here if I am taking 60 degree, then AD is my perpendicular. So AD square equals to AB square minus BD square. So AD square equals to AB is A square minus A by 2 whole square. So A by 2 whole square is A square by 4. So AD square equals to A square minus A square by 4, which is equals to 4A square minus A square by 4. So we can say that AD square is equals to 3A square by 4, and if I take the square root, I get 3 by 2, no, root 3, 1 minute, yeah. If we took the square root here, so it is root 3A square by 4, which is equals to A by 2 comes out and root 3 stays inside. Okay, so A by 2 root 3. So this is the value of my AD, right? Now let's write here, okay, A root 3 by 2. Now we can find the value of sine 30 and cos 30, tan 30, all, and 60 degree. Both the values I can find from this triangle. So now I know the length of all the sides. This is why I took equilateral triangle and I did not take right angle triangle directly. I took equilateral triangle and then I dropped a perpendicular to make it right angle and divide the angle, so that I get the value of my all the sides. So now let's redraw it, because otherwise it will be difficult for you to see and understand. So I will draw it again. One part of the triangle I'll draw for us. I'm just copying this triangle here, but not the full triangle, because these both are congruent to each other. So I'm just taking one triangle to make you understand it better. So let's take here, this is my A, B and D, and this was my 90 degree, this is my 60 degree, and this is my 30 degree. This was A by 2, this was A, and this was root 3 by 2A. Correct? So this is what we found in the previous triangle. So I have just written that below. Okay. So now if I want to write sine 30 degree. Okay. So now I am writing sine of 30 degree. So let's write Pandit Badri Prasad Hari Hari Bhole Sona Chandi Tole. So sine 30 is perpendicular upon hypotenuse. So now the important thing here is, when I am taking sine 30, my base is AD, right? So my base is AD and perpendicular becomes BD. So here when I am taking sine 30, so I will writing BD upon AB, correct? So what is the value of BD here? BD is A by 2 and AB is A. So A get cancelled and the value of sine 30 is 1 by 2. Now if we look at the here only cos 30. Okay, cos 30 is base upon hypotenuse. So I told you I am taking 30 degree. So my base is AD upon AB. So this will be A root 3 by 2 upon A get cancelled. So this is root 3 by 2. And what about tan 30? So tan 30 I can write directly also that it is sine 30 upon cos 30. So 1 by 2 upon root 3 by 2. These 2's gets cancelled. So 1 by root 3. So this is my tan 30. Now let's find the remaining three trigonometric ratios here only. So cosecant 30 will be 2. Secant 30 will be 2 by root 3 and cot 30 is root 3 upon 1. So this is how we find the values for 30 degree when trigonometric ratios are at angle 30 degree. Now let's do 60 degree also here. So I'll take another color. So now here when I am saying sine 60, see now my base changes because I am taking 60 degree. So base is BD and perpendicular is AD, correct? So this is perpendicular upon hypotenuse. So AD upon AB. So children, as I told you in my previous stream about complementary angles that we will be learning about complementary angles. So that topic I'll cover tomorrow. But I want you to just observe here that when I found cos 30, it was AD upon AB. And what is the complementary of 30 degree? That is 60, correct? So Aryabhatta told sine as ardhajaya and cosine as kotijaya, right? So when I told you, if in you see in English sine and cosine complementary of sine, so cos 30 degree is complementary of sine 60. So if you just look here that cos 30 is AD by AB and sine 60 is also AD by AB. Just observe this. I'll be coming on this tomorrow with more details. So now AD is A root 3 by 2 and AB is A. So I am getting the same values. That means sine 60 is equals to cos 30. Okay. So now when I comes to cos 60, so you can just tell me that cos 60 shall be equal to sine 30 because they are here complementary in the same triangle. If you look here 60 degree and 30 degree, I just want you to observe it today because the proofs of these I will cover tomorrow. Okay, so cos 60 is base upon hypotenuse. So my base is BD and hypotenuse is AB. So BD is A by 2 and AB is A, and this get cancelled and I get 1 by 2. So you can see that my sine 30 and cos 60 are equal. Now if I look at tan 60, I can just divide root 3 by 2 upon 1 by 2. They both get cancelled and I get root 3. Correct? So let's write the remaining trigonometric ratios. Cosecant 60, it will be equal to 2 by root 3. So secant and cosecant, complementary of secant, right? So secant 30 and cosecant 60, they both have the same value. Now secant 60 is equals to 2 by 1, which is same as cosecant 30, and cot 60 will be 1 by root 3. So these are the trigonometric ratios, which are very, very important, and I hope you are clear with the proofs also, that how they are derived from a triangle, right angle triangle, and how from equilateral triangle. Okay, so now let's move on to sine 0 degree. Okay, so I hope you are clear with the concept of whatever we have learned so far. So we have learned about 45 degree, 30 degree and 60 degree. So now to learn about trigonometric ratios at 0 degree, let's draw a triangle, right angle triangle. Okay, so this is my right angle triangle, which is right angled at B. When I am saying trigonometric ratios at 0 degree, okay, so that means my angle A should become smaller and smaller and smaller. So I will be highlighting this in some other color. So that means this angle A should become smaller and smaller and smaller. So can you just look here that when it is becoming smaller, side BC is decreasing, correct? So here when I am making this angle is smaller, this C will come down and then this C will come down, and gradually when it become more small and small, this C will come down. So length of BC is decreasing, correct? So length of BC is continuously decreasing to make angle 0, and eventually AC becomes equal to AB, correct? When angle A approaches 0 degree, by decreasing the length of BC gradually, then AC and AB, they become equal, they actually coincide, correct? So when this kind of case is there, so sine 0 degree, okay, is perpendicular upon hypotenuse. So here BC is my perpendicular, okay, and BC upon AC, and AC has coincided with AB, but the length of BC decreased to 0, right? It is approximately 0. So 0 upon AC will be equals to 0. So that means sine 0, value of sine 0 is 0. And what about cos 0? Cos 0 is base upon hypotenuse. So AB upon AC. And we know that AB and AC have coincided. They are almost equal. So when AB and AC are equal, we can say that, okay, they both get cancelled and it is equals to 1. That's why cos 0 is 1. And tan 0 will be equals to sine 0 upon cos 0. 0 upon 1 gives you 0. So these are the values of sine 0, cos 0, tan 0 when angle A becomes smaller and smaller and smaller, and length BC decreases to 0, and hypotenuse and the base AB, they coincide. Okay, so that's why. Now let's look at the remaining 3 trigonometric ratios. Now cosecant 0 will be equals to 1 by 0, which is not defined. We cannot define it, right? When we are dividing by 0, we cannot define it. Now secant 0 is 1 only, 1 upon 1, right? And cot 0 is again not defined. So these are the values of trigonometric ratios when theta is 0. Okay, so I hope everyone is clear. Those who have tuned in and watching my live stream, please post your queries if you are not clear with any concept. Okay, so I'll be back with theta 90 degree. Okay, so now when my theta is 90 degree. So earlier when theta was 0 degree, I made my angle A smaller and smaller and smaller. Now when theta is 90 degree, that means I want to increase my angle A. So let's draw one triangle to understand it. Okay, so this is the right angle triangle, which is right angled at B, and this is my theta. Okay, so now if you look here, to make theta 90 degree, I want to increase this angle. Okay, so if I bring this here, this theta over here, then my C becomes smaller and this theta becomes bigger and bigger, and you can clearly see that when I am moving my theta towards B, towards 90 degree, the length of AB is decreasing and angle C is also decreasing, correct? So angle C becomes smaller than what it was because angle A is increasing. So we know that in a right angle triangle, all three angles depend, two angles especially, angle A and C, they depend on each other because we have kept it at angle B 90 degree. So when angle A is increasing, angle C is decreasing, right? And the length of AB is also decreasing. So now finally a point comes when A and B, they coincide, right? Point A gets closer to B. So if you just look here, C gets smaller and smaller and smaller, and this point A, it is moving closer and closer to B to become 90 degree, right? So when your angle A becomes 90 degree, your AC and BC, they are almost equal. They coincide actually. They coincide and they become equal. Okay, but your AB diminishes because A and B coincides. So now at that point, when I'm saying sine 90 degree, that is perpendicular upon hypotenuse. So here my perpendicular is BC and my hypotenuse is AC. So BC and AC, as I have mentioned, that they coincide, that means they become equal, BC and AC. So it is equals to 1. But for cos 90, like we just observed in the previous case where it was complementary, so cos 90, it is base upon hypotenuse. So my base is AB and my hypotenuse is AC. But in this case, AB has almost diminished because A becomes so bigger that length of AB decreased and decreased to 0. So that's why cos 90 is 0 degree. And tan 90 is sine upon cos, sine 90 upon cos 90, so that you cannot define 1 upon 0, so it is not defined. Now if you look at the other trigonometric ratios, cosecant 90, secant 90 and cot 90. So cosecant 90 is 1 and secant 90 will be not defined and cot 90 is 0. So these are the important trigonometric ratios that are very important for board perspective, because definitely one question comes in board exam based on the angles. So when you solve height and distance question or other normal questions, you need to know the values. Okay, so let's just look at the chat. I think okay, hey Vanch, yeah, welcome to Deep Tips. So today we were learning about the trigonometric ratios. The part you have missed, you can just refer to the video. Okay, so now I am going to tell you a very important thing that I feel all grade 9 and 10 students should know. This is a trick of the today. So I am about to finish this topic. I have told you how to derive the trigonometric ratios of important angles 0, 30, 60, 45, 90 degree. But now I am going to tell you the trick and tip That is the specialty of deep tips, that how to learn the table of trigonometric ratios. Okay, so learn it and just observe it very carefully. It's fun to know this. Okay, so now children, for table of trigonometry, first thing I'll write here sine, cos, sine, cos and tan. On the top I'll write 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Okay, so let's change the color now. So now observe the main thing. 0 degree, 30, 45, 60, 90. You will just learn this in 1 minute. This is my challenge, that you are going to actually learn it in 1 minute. So now just observe. Write 0, 1, 2, 3, 4. Okay, so first you will write sine, cos, tan and all the angles on the top, and then write 0, 1, 2, 3, 4. Now divide all the ratios by 4. Okay, 0, 1, everything by 4. Now next, put a sign of root, square root. Okay, and we know this is 1 by 2. If you cancel this 2 by 4, simplify it. So now here is the Eureka movement. So 0 by 4 gives you 0. Okay, root of 1 by 4 gives you 1 by 2. And this is 1 by root 2. This is root 3 by 2. And this is 1. So here are the trigonometric ratios of sine just by this simple trick. Now if you need to write the remaining, just a minute, yeah. Okay, so now you need to write the remaining cos and tan also. So what we will do, we will just do crisscross. So 1 comes here, root 3 by 2 comes here, 1 by root 2 stay here. Okay, the center stays the same. 1 by 2 moves here and 0 comes here. Okay, so we know tan theta is sine by cos. So 0 by 1 gives you 0. 1 by 2 upon root 3 by 2 gives you 1 by root 3. 1 by root 2 upon 1 by root 2 gives you 1. And this is root 3 by 2 upon 1 by 2 gives you root 3, and 1 by 0 gives you not defined. So I think this is just a 1 minute trick where you write the table in 1 minute. I hope you are clear with the concept. First you wrote 0, 1, 2, 3, 4. Then you divided everything by 4 and took the square root. So when you took the square root, you got 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. And then you just did crisscross. What you got for sine 90, you wrote for cos 0. What you got for 60, you wrote for cos 30. And 45 stays the same, and 30, complement of 30 is 60, so that's why you wrote 1 by 2 here, and complement of 0 is 90. As I am telling you again and again that cosine means complementary of sine, and tan is sine by cos. So this is how you learn the basic trigonometric table of 0 to 90 of those important ratios. And if you have to write cosecant, secant and cotangent, you can just do the reciprocal. So this is all about the trigonometric ratio table. So yeah. Okay, so I hope everyone is clear with the concept. So this was all about trigonometric ratios today. So children, tomorrow we will be solving the questions based on these ratios. So tomorrow's session will be specially on board exam questions on trigonometric ratios table, and I'll cover a bit of complementary angles also, because in CBSE grade 10 we do have complementary angles, but in ICSE we don't have, but it's always good to know. But in grade 9 ICSE they do have complementary angles. So tomorrow we are going to learn about the questions based on these trigonometric ratios. I hope you are clear with the concept today, and happy Pythagorean day. So special 16th December that we discussed in the beginning. So stay tuned to Deep Tips. Thank you so much for watching this video. Okay, bye bye.